let me just introduce myself. My name is Mustafa Öztürk. I'm the Chief Operating Officer of ProManage. Um, and we are at ProManage. I'm just going to give a little bit of intro to the ProManage. We are we are the leading provider of digital manufacturing solutions since 1998. So we've been working on digital manufacturing for the last 24 years. And Chicago is our headquarters of international operations. In terms of products, the only thing that we work on is IoT-based digital manufacturing systems. So ProManage is our product, and we also develop IoT devices for data collection. When it's possible, we use machine PLCs to collect data. But in some of the older machines or with machines where there is no PLC, we also have our IoT devices for data collection from the machines. We also work on AI, artificial intelligence, machine learning, deep learning implementations for manufacturing. For manufacturing, we have predictive maintenance or predictive quality solutions where actually you are not only collecting data in real time or when or you're reporting the historical data, but you are now with the predictive tools. Now you can actually predict the future, where you can predict whether the machine will have a failure or whether the machine will start having quality problems. In terms of industries, we are in all of discrete and batch manufacturing. So automotive, metal processing, home appliances, plastics, food, FMCG. Those are the areas where we're heavily present. In terms of R&D, we are an R&D company, so we are mainly selling the product that we produce. So we are about right now 130 plus engineers working on our platform, and we have typically four types of engineers: electronics, mechatronics, computer, and industrial engineers. The electronics engineers are the ones responsible for developing our IoT devices. Mechatronics engineers are the ones that work in the shop floor with the machines to collect the data with the connections and how to the best get the data out of the machines. Computer engineers are developing our software and maintaining and upgrading it continuously. And industrial engineers are the ones that work with manufacturers. Since they have seen a lot of different applications or a lot of different types of manufacturing, they can work with the manufacturer to implement the solution, to guide them, train them, and have them the best success in terms of improving their production processes with the use of the digital tools that we'll talk about today. So we are a global company. We are in 5 different continents: North America, South America, Europe, in Asia, Japan, China, Vietnam, and also we have presence in Africa. Right now, we are tracking more than 30,000 plus machines with more than 300 customers, and like I said, we are in 5 different continents working on the system. So these are some of our customers. Like I said, we have more than 300 plus customers. Some of the names that would be recognizable to you would be 3M, Haribo, the gummy bear company, Siemens in some of their factories are using our solution, Schneider Electric, Lincoln Electric, Nitto Bento, Bosch Siemens Home Appliances, Grainger Packaging, Maxion Wheels in automotive, ZF in automotive, Mondi in packaging. So we have a lot of different verticals, different industries that we work with, and our industrial engineers have experience with a lot of different types of manufacturing. So some of the typical gains, again, you can find these gains in our website, promanage.com. You can go and look for our references. We have written statements from the customer, and those are the statements, since those are the ones that are coming from the customer, we can easily publish them. So Bosch Siemens Home Appliances, these are typical 18% improvement in their overall equipment efficiency, 20% reduction in breakdowns, and 30% reduction in their setup times. Maxion, this is a aluminum wheel company. They have 20% improvement in their overall equipment efficiency, 75% reduction in breakdowns, 80% reduction in setup times. So these are typical improvement when you start using smart manufacturing solutions. So in terms of value proposition, this I think slide explains it very well. So for any company, for an average company in USA, machine utilization is about 40%. That means within a given time unit, you're only using 40% of that time for the machine for useful products that you can sell. The remaining 60% is actually wasted. It can be wasted in setup times when you're trying to set up your machine, waiting for a material. It can be a raw material. The machine could be waiting for a semi product. It could be waiting for a tool. So that's another loss. Machine failures. The machines do fail. They need maintenance. So machine failures are also a significant component. And then quality losses are kind of the worst type of losses, where you produce a product, you spend all that time and energy, the physical energy, and you only have it, you lose it for quality. So 40% typical. Any company that we go to, we start measuring the data in real time, we'll typically see around 40%. Some companies are lower, some companies are higher than 40%, but average is about 40%. If you want to be a world-class manufacturer, you want to be at 85%. So with smart manufacturing, we are guiding you to go from 40% to 85%. We are actually, in other words, we're trying to measure all of these different types of losses and try to reduce them so that you are actually using 85% of the machine time for useful production. So what does this mean to go from 40 to 85%? Given you have the same number of machines, it's actually doubling the amount of production for the same machine. It's as if you bought, if you have 50 machines, it's like you had bought and went and bought another 50 machines to do production. And this is very big gains. So this is another typical improvement graph. So this is again one of our customers. At the end of 2016, they went live with the system. They were producing about 161 units or 161 products per hour. So this is equivalent product per hour. That's how they measure their efficiency. And then they gradually improved up to 200, about 40 products per hour. This is going from 160 to about 236. So this is very close to 50% improvement in production speed. That means if you have a lot of orders, you can fulfill them. If you don't have orders, actually you can use this time to reduce working days or to improve employee satisfaction. Okay, so how does a typical topology for a smart manufacturing system look like? So you can think of the gray box here as your factory, and these are your machines and operators. So for a machine, a smart manufacturing should be collecting data in real time. It should be collecting the data digitally, automatically, and reliably, right? So we have this machine, and then if the machine, so there are two ways we can collect data. One way is if your machines are smart, they have PLCs in them. They support common protocols like OPC UA, MT Connect, Euromap 63 in plastic injection. For CNC machines, there's MT Connect, Focus, and other protocols. There's MQTT. So there are a lot of common protocols that our system supports natively. So if your machines have those systems, we can actually directly connect to those systems with an Ethernet cable, and we would just install an edge software on the factory floor. It could be just a simple PC or a server or a virtual server. This edge software, it's a very small piece of software. You can even install it on a notebook, and then we would just directly connect to your wireless local area network, and the edge software will be collecting data directly from the PLC. If there is no PLC, if your machines are older or they don't have the PLC capability, Then we would have our IoT devices, which we call smart counter, and they would be connecting to the digital outputs of your machine, and they will be collecting production data. Depending on different packages, we will have an operator interface where the operators can enter some type of data. They can start work orders, they can enter scrap reasons. But at the end of the day, all we have to do is install an edge software on the on your factory, and the data will be sent to the ProManage Cloud, which is an Oracle cloud infrastructure. And you can actually, once the installation is done, actually you can access your data wherever you are in the world. It could be wherever there is an internet connection or a web browser. You'll be able to see your production amounts, stoppage reasons, uptimes, downtimes, etc. And the operator interface can be a tablet, or it can be a PC, it can be a notebook, it can be a touchscreen panel. So again, anywhere there's internet connection, you can have, as long as there is internet connection, the operators can enter the production data. So this would be a typical topology. So if you have multiple factories in different parts of US or in different parts of the world, actually you would have just a replicas of this infrastructure. And then again, the data will be sent to the ProManage Cloud. We have different data centers around the world. We have Frankfurt, we have US locations, we have Japanese locations. So depending on where you are in the world, the correct data center will be getting the data and showing you the results. So in terms of barriers, so there is for manufacturers, there are a lot of different barriers they have in mind. So the first barrier that they are kind of scared about is the effort. So how do I install this system? How long does it take? Do I need a lot of support? So actually, before we developed ProManage Cloud, in a typical smart manufacturing system, what you would do is there would be an analysis phase where we would go into the factory, look at the machines, try to analyze them, and try to find the best way to connect. But with ProManage Cloud, actually, it's a no-code platform. So since we have seen so many different production processes, we have seen plastic injection, CNC, a lot of different machines, press brakes, injection molding, blow molding. So a lot of different experience. Now we could actually make this as a product. So there is really, we don't have to do anything specific, no coding for you. So all we have to do is we have a configuration tool now. Depending on what type of production process you have, whether you have a CNC or a machining production process, or a plastic injection process, or your product definitions might be, each company has a different product definition. So with the configuration tool, actually we can just configure it, and we don't have to really write code specific to you. And it's a cloud-based platform, so we can just start a company, and then we can go to your site. Depending on whether you have a PLC or your machines are older, we would actually only be taking a day to do the installation. So the installation takes 1 day. The system goes up and running immediately. We'll just do your configuration, and actually in 1 day you would have a smart manufacturing system. So that this is the effort actually it would take for a typical company. And since it's so simple, this is applicable for, typically smart manufacturing is seen as a tool for large enterprises, but now actually we have companies in our portfolio where there is only 2 machines, 3 machines. I just visited a company yesterday, one of our customers. He has 3 machines, and then he can actually see the whole factory wherever he goes. And what he said is he could actually now focus mostly on sales and marketing activities, and he just tracks the production from his application. And then when he sees there's a problem, since this is a small company, he can just call the guys and try to figure out what the problem is. But now he can fully focus on sales and marketing activities. So the second concern the manufacturers have is it's sometimes just too much of work for the manufacturers in terms of if they do it in one step, because typically a manufacturing operations management system is a complex system. So what we have is we don't necessarily want you to go fully into the system, but we want you to do a step by step go into digitalization. So you can start from simple machine monitoring, and then you can upgrade as you go when you feel the company culture is ready, when you're ready, when you're confident with the first step, then you can go to the next step. I'm going to talk a little bit more about what the steps are. And once you have the full advanced functionality available, you can actually have additional modules on top of the advanced functionality. Like you can actually now manage your maintenance operations. You can manage your quality operations. You can have the energy module where actually you can track energy consumption per product. So, and actually you can go all the way to artificial intelligence, which I talked in the beginning, where you can go all the way to predictive operations management, where now you are not only looking at your data in today, but you actually can predict what's going to happen in the future. But we don't want the manufacturer to do this in one step. We want them, we have the option to have them in different levels. So let me just actually explain this a little bit better. So we have 3 separate levels. The first level is on mobile, which we call monitoring package, where in this one actually there is no involvement in the shop floor operators or technicians. It's just background data collection. And with this, what you have is real-time machine monitoring, where you can actually track your production quantities, run and stoppage intervals, cycle times are recorded by machine, date and time, and you can actually start analyzing your production history. You can start analyzing what's my machine's uptime, downtime, etc. So once you are confident with the monitoring package, now you have a good idea of what each machine is producing, what's the uptime, downtime. You can actually go to the digital package, where now you can actually invite your technicians and operators into the digitalization. And the operators and technicians actually will be entering data to the system, and they'll also be tracking their own KPIs, like how many I produced today, what's my uptime, downtime, what are my biggest reasons for stops, what are my scrap amounts, what's the reasons for scraps. And now you can actually start improving your production operations or production process, where now you know what your bottlenecks are. And now you can try to do root cause analysis and start to eliminate, because now you know what's the biggest losses within your factory or your machines. The third package, now once you're actually ready and your operators are inside in a part of digitalization, they are entering data into the system. They're actually tracking their own KPIs. They're trying to improve. The third package would be connected. Now you have product and work order data. You have workstation-based real-time planning. If you like, you can do the real-time planning within the system, or you can do it in the ERP and integrate into our system. So now you have the optional ERP integration package. We have now with the connected package, actually you have a full manufacturing operations management functionality. So we don't necessarily want you to start directly from the connected package, because sometimes this is hard. What we do is you start with mobile, and we track certain KPIs, and then we actually try to have you ready for the digital package, where you now try to list your stoppage reasons, scrap reasons, start training your technicians, and then we go to the digital package. And once you're ready with the digital package, now we want you to go to the connected package, which is the full manufacturing operations management functionality. So in terms of the functionality, with the on mobile, we have ready-to-use cockpits, ready-to-use reports. It's a plug-and-play solution, so it doesn't require much involvement from the manufacturer side. So we have the shift definitions, customizable machine definitions, and in all of the packages we have automatic data transfer to BI tools, and we also have the module that we call ProGuard, which means if I have time, I'll try to demonstrate it, but it actually monitors your KPIs for you. For example, if you have targets for certain stoppages, let's say you have a target for machine failure, you want your machine failures to last maximum of an hour. As soon as the machine failure stoppage is more than 1 hour, you'll have escalated warnings coming your way. So with the digital package now, in addition to what we have on mobile package, now you have the operator technicians involved, so they can actually log into the system. They can enter stoppage reasons, scrap reasons. Actually, you can enter them in 3 form. You have ready-to-use reports, ready-to-use cockpits. Again, we have the automatic transfer to BI tools. With the digital package now, we have more involvement from the operators and technicians for entering stoppage and scrap reasons. With the connected package, again, it's a no-code system, so it's completely customizable. And now we have the product and work order structure. Basically, we know what products you're producing, the system knows, and the operators can actually start work orders with the system. Also, we have ready-to-use reports with the connected package, but we also have customizable reports, which means you can actually have we give you a design tool for reports. So it's not just standard reports, but you can actually design your own reports, and you can actually design your dashboards. So the dashboards are, again, fully customizable. Let me just check if there are any questions, and then I'll get back. So there was a question asking whether we work with small businesses. I think I have answered that question. So we do work with small manufacturers, actually, even with the ones that have 2 to 3 machines. And we like working with small to medium manufacturers as well, because they have so much improvement that they can have with these systems. And we have made the system useful also for small to medium manufacturers, and easy for them to be able to use it. Okay, so in terms of infrastructure, this is again one area where especially small to medium manufacturers have not a full grasp on. It's the infrastructure. It's both the infrastructure and the cost associated with the infrastructure. So typically, for a smart manufacturing system, comes with an investment in terms of servers, database installations, a full structure that goes around it. With our solution, actually, you basically have almost zero IT infrastructure investment that you have to do on site. What you have to do is, I'll explain it in the topology as well, but we need to have an internet connection. So you need to provide the system an internet connection, because the data is in the cloud. We need a PC. This is a very low cost, or this is a very low requirement PC. It can be a standard PC or a laptop that you're using, or it can be a server or a virtual server, but a standard PC is enough. What we have to do is install the edge service within that PC. We can provide the PC, or you can give us any standard PC. So we will install an edge service. If you are using either the digital or connected package, you would need an operator interface. But the operator interface can be a PC, it can be any tablet, it could be a touch panel PC or a mobile phone. You can actually be using one operator interface for multiple machines. So if you have a small company, like if you have 5 machines or 3 machines, you can put one PC, and the operators could be entering the data associated with their machine into that one common PC. So those would be the only things we would need. We won't need any database installation. We won't need any infrastructure. It's just providing an internet connection. It's an Ethernet connection within the company, or a Wi-Fi connection. We would need a PC, where we would install the edge service on it. And then if you're using the second or third package where you have the operator interface, that has to be installed, or that has to be actually accessed. There is no installation, since it's a web-based platform. It just needs to be accessed on a PC or a touch panel or tablet or a mobile phone. Even a mobile phone would work because it's a web-based interface. So it's really very low cost system with basically no infrastructure needs within your factory, because we are taking care of the infrastructure, the IT investment in the cloud, where we use Oracle Cloud Infrastructure. Okay, so just want to explain this a little bit better. So if this is your factory, all we would need is this HPC. So again, this is you can think of it as, to make it more concrete, it could be like an 8 GB RAM, standard CPU. We would only need probably 100 GB of hard drive on this. So any PC today would satisfy. And then all we would need is an internet connection that connects our ProManage Cloud with the edge. So that would be all the IT infrastructure that we would need. Let me just double check again if there are any questions. So there's another question about whether we work with machine manufacturers. Let me just share the screen again. Yeah, we actually work with a lot of machine manufacturers. Some of them we work with as white label. Some of them actually are using the ProManage system. What we would do with the machine manufacturer, so I can maybe give a single name. I can give more names, but some of them are I should not be naming names. But Yoshino in Japan is one of the machine manufacturers that we work with. So what we would do is we would actually integrate with their machines. So typically they have a PLC, so the system would come bundled with the machine manufacturer. So all we have to do is when the machine goes to their customer, all we have to do is just install the edge service in the factory, and the system would be up and running. So the connection of, or the integration of the edge with the machine PLC would already be done with the Yoshino, for example, PLC. So all we have to do is just set up the edge, and the system will be up and running. And typically with machine manufacturers, it's not just production data, but there's a lot more data that we can actually work with that helps both the machine manufacturer and also the customer of the machine user. Okay, I think there's another question. Let me just stop the screen sharing. Okay. So there was a question with if we can do a POC with 5 machines. So I'll actually answer that very soon. So actually in this slide, I think we are already answering that question. So in terms of budget, so we have, our model is machine-based pricing. So you can have unlimited users. We would only charge per the number of machines you have. It starts at $45 per month per machine, but we have the pricing actually goes down significantly as the number of machines increase. So we can provide pricing, but the pricing is you can think of it for 10 machines. It's less than $400 per month. So you would be only paying, if you have 10 machines, you would be paying $400 per month. Which would be just, it would be actually less than the mobile phone usage for a couple of users within the company. So you should, we're spending all this money on a lot of different things. This is for a manufacturing company tracking their production KPIs. We can do it with a very small fee. And since this is a cloud based system, and since we made the system so easy to install, we can actually do a proof of concept with a couple of machines. So the question was if you could do a setup with 5 machines. Yes, we can. You can actually get the system for 5 machines. You can actually you can actually prove the value, and then you can install it to the whole to the all of your machines after that. So you can actually even do a 5 machine POC with the basic package, and then you can upgrade it as you want, or you can install it to the other machines when you see the value. And we think that maybe is it the let me just skip a little bit into ROI. So if you can install this to a machine, to 5 machines, sometimes actually you can see returns on your investment as fast as 1 week. This is, I mean, this might seem strange to you, but we have one example where the company name is Labsan. Actually, we have a YouTube video on this. I'm gonna share the link of this video after the meeting. But Labsan is a medical device manufacturer. They have plastic injection machines in their factory, and they work 3 shifts within. So they work 24/7. Once they installed our system, they actually did the basic package, the mobile package. What they have noticed is their over the night shift, their machines were stopping 18 times on average, and each of these stops were about 20 minutes. They did not know about this. They did not notice this before, but once they installed the system, immediately they have noticed that the machines were stopping 18 times within the night shift. And when they analyzed it, they realized that it's the machine had a mode where he's actually perceiving that there is a problem with the machine. So it would just, for safety reasons, the machine was stopping itself. And what has to happen is operator come to the machine and push the button and let it keep going. But because it's the overnight shift, they don't have operators, or they don't have one operator per machine. So it would take them on average about 20 minutes for the operator to realize the machine had stopped, and he would go and push the button, and the machine would just keep going. But they did not know about this problem. And once they started getting the data, they realized there's a problem, and then they actually did a very simple improvement on the machine PLC, which would actually allow them to keep going even though the machine perceives that particular failure mode. And actually they had saved a lot more than the price that they gave us just by noticing this. And the rest, they actually they keep improving their systems, and they actually have upgraded to the digital package, where now they have the operators and technicians involved within the smart manufacturing system. I also encourage you to look at our website. We have reference letters written from our customers. I had actually talked about some of the improvements. They had given us the improvement in their systems, and there are a lot of different aspects of the improvement. It doesn't have to be just the number of production per hour. It could be some of them have a lot of improvement in terms of their documentation time. Some of them talks about how they improve their production managers' time. So they have reduced their documentation time and analysis time, so that they can only focus on improving the production after they have installed the system. So I encourage you to look at the reference letters and look at the YouTube video for Labsan and see how they actually can they have improved their system very quickly. So let me go back. So we talked about budget, and then in terms of trust, we have done this in more than 300 plus factories, as I mentioned, and we're tracking more than 30,000 machines, and we have customers in 5 continents. So again, I want to talk about some of them, and again, like I said, this is from home appliances, automotive industry, plastic injection, FMCG. So there are a lot of different industries within these companies. So again, like I said, some of the known names, 3M in some of their factories are using our solution. Haribo Gummy Bear Company is using our solution worldwide. Siemens, Schneider Electric, Stackpole, Lincoln Electric, Beko is a very is the biggest home appliances company in Europe. Bosch Siemens Home Appliances, Wavin, ZF, Maxion Wheels. Denso is one of the biggest suppliers of Toyota. Aishin Group, again, those are owned by Toyota and one of the again biggest suppliers of Toyota. So we have talked about investment and ROI. So another topic is continuous improvement. So this is a system, or this is an industry where actually you have to be improving. When you are improving your manufacturing operations, the system has to also be continuously improving. So what we do is we actually have a lot of advanced functionality, but we would continuously seek feedback from our customers, from our customer base. So as I said, we have more than 300 customers, and we would be getting continuous feedback from them on what to improve. And we have an engineering group of more than 100 people. So we would be selecting those ideas and continuously improving. And since this is a cloud-based solution, the improvements will be automatic, and you'll actually see the system improving. Added more functionality, more modules will be added to the system. If I have time, I'll do a quick demo. But we have a lot of advanced features. So sometimes manufacturers compare our solution with standard monitoring solutions, but this is not a monitoring solution by itself. Actually, we help you manage your production operations. And to be able to do that, we have a configuration tool, and the configuration tool actually lets you configure your system specific to your production operation. So if you're using a plastic injection machine versus a CNC machine, this tool would let you specify your type of production. It will also let you define your product. So the way you define your product, it might have height, weight, product ID, product code. It might have order ID. It might have a lot of different fields. This configuration actual tool will let you select what those are. The way you start a work order in the shop floor might be different. You could be some companies select product code. Some people might have work orders. Some companies might have planning done by the planning department and assigned to machines. So depending on how you manage those production operations, the system actually will let you configure specific to your own company. So we have dashboard customization. So this is very important because different roles within the company want to look at different metrics, different KPIs. Production operations want to look at production metrics, how many they produced, what's my cycle time when I produce a product. They want to analyze the production metrics. Quality team will want to look at quality metrics. What's my scrap amount? What's my biggest reasons for scrap? Did I meet my scrap targets? So this dashboard customization tool will let you design dashboards specific to your needs, and each user might be looking at different dashboard. Each user might be looking at, or each group might be looking at different dashboards. We have a tool called ProGuard, which actually will be watching those metrics for you. So you might have a target for, let's say, scrap ratio, and as soon as that target is exceeded, you'll get an alarm either through your email within the system or within the app. You can also have any report that you generate within the system be emailed to you regularly whenever you want. So you might want to look at your data production report sent to you at the end of each day. So you don't necessarily have to go log into the system. The system will actually send you the report whenever you want. We have report factories, which again, monitoring tools won't let you have. These, we don't just give you reports, we'll give you report factories, which means you can actually design your own report. We give you fixed reports, but we also give you report factories for advanced packages where you can actually design your own reports. We have visual, list, and Excel reports. So any report that you have, you can uh, graphically see it. You can also see the list reports, and you can also export any of those reports to spreadsheet. And we have integration to BI tools or to ERP systems, which means any data that's generated within the system, you can actually automatically on the background send it to your preferred BI tool like Power BI or Tableau. And that's useful when you want to combine production data with, for example, financial data, right? You want to know how many you produce, what's your scrap, and you want to see what's the dollar value associated with it. So you can use BI tools, and the system in any of the packages will let you do the integration on the background seamlessly. So this is already built into the system. So in terms of cultural transformation, this is again one of the concerns that the companies have. How am I going to transform my culture from a standard company to a smart manufacturing company, and how do I have my employees engaged within the digitalization? I don't, it's very hard to be successful when you don't have your employees engaged within this cultural transformation. So we have again, this is we have different tools to have you succeed within this. So the first tool is we want you to have a phased approach to digitalization. As I mentioned before, it's sometimes too much to do it at once. So we want you to do it in baby steps. So the first step is again just collecting data, making sure you have real-time data collected in the background, and then you can, once you have those reports and once you see the value, then you can gradually have your operators and technicians involved, and then later you can integrate with your ERP system, have the full package. And as the company, as the employees in the company see the benefit, and as they actually will start tracking their own KPIs and improving their own KPIs, now you can actually add even more modules. Like I said, you can start managing your maintenance operations, quality operations, energy operations on top of the manufacturing operations management. We also have on-demand training videos for how smart manufacturing works, how the system works, and how do you improve your manufacturing processes with ProManage. Right. So we also help you. We have a library of videos. It's on demand, so any of your teammates or team members might be watching these on demand. When we actually install the system, we do this with our industrial engineers. They will actually help you get up to speed in terms of installing the system. They'll be giving you training, but on top of that, what you can do is with after the system is installed, we can actually have weekly consulting sessions from our digital transformation experts. So they would sit with you and they would actually look at the data that you have, and they'll actually guide you to use the system, and they'll guide you to how you can improve your system with the data that you have. Since this is a real-time system, actually you'll be looking at the data in real time. You'll be looking at reports, maybe weekly reports, monthly reports, and you'll see your bottlenecks, and they'll help you how to get the most out of the system, and how they can actually share the experience that they have gained from a lot of different manufacturing processes within different plants. Okay, so this is all I had. Let me see if there are questions. And we have about 15 minutes, so I can do a quick demo of the system within that time. Okay, so there was a question for a code, so we'll send you a code for the solution after the meeting. Let me actually share. Let me just do a quick demo of the system. Okay, I think you can see my screen. So I have about 10 minutes, so I'll try to do like a quick demo, try to explain the basics, but 10 minutes is definitely not enough to do a full demo. So let me know after the meeting if you want to see a longer or a full demo. So um, let's start with the online monitoring screen. This would be the screen where we would be seeing all the machines in one shot. So at this system, I have two machines called machine 1 and machine 2. And now I'm looking at the real-time data that's coming out of the machines. So machine 1 is producing part 2, machine 2 is producing part 1. There's some details about the part. So total time this job was running, what's the stoppage time, what's the running time, how many I planned. So I had planned for 5,000. So far I have the remaining quantity is 4,000. So far I have produced 545. I have no scraps. Some of the speed values, so I have been producing at about 28 seconds per product. And this is the remaining time for this specific job order that I have. You can see the system, both of the machines are running, and none of them are stopping or none of them are offline. Actually, I can change the information type that I see here. So I can, for example, select shift. If I select shift, then the data that's associated with the shift will be shown here. So how much time has passed in the shift, what's the total stoppage within the shift, what's the runtime, how many I produced within the shift. So I can select different information type. So different, I can actually design the data that I want to see here within the system. We have more than 300 KPIs, so you can actually design whatever you want to see within this online monitoring tool. I can also actually filter. So if I have any, let's say, if I have a technician, if there's I can look at, if I'm a technician, I can be looking at this screen where I have this part selected. So a technician call. So obviously none of the machines have technician call, so this will not bring any machines here. So let me share the dashboards. So let me share. So we have built-in dashboards. So this is one of them. What this dashboard is showing me is the machines. So I'm looking at machine 1, how many I produced so far within the shift, how many I should have produced this if I didn't have any losses within the system. So for this case, I have about 200 products that I have lost within the shift. So this graph shows me the cycles. So how many I produced in the last 24 hours within 1 hour intervals. So I can see if there is any reduction in my speed. Or if I had more stoppages. And this is my average cycle time within the last 24 hours. So there are different dashboards here. Like I said, depending on the package, you can be looking at different, you could be designing your own dashboard. So this is typically the one that the operator looks at. So how many he has produced, what's the speed. So 30 seconds per product without stops. That means the long stops are reduced or taken out from the calculation. 36 seconds is just with, considering all the stops. That's my speed. So what's my completed production so far as an operator? This operator at this time is behind in production about 536 units. So this is the current target and this is the shift target. So you can actually see, the operator can see the production amounts with respect to the plan. So you can see the scrap amounts within the shift for the operator. If there were any scraps, you can see all this. I'll quickly show the machine history tool. So this tool actually lets you see the production amounts, the stoppages. Let me do an 8 hour, last 8 hours. So here actually you can see each and every cycle of production. So every time there is a production, this cycle will increase. I can see my stoppage point. So you can actually see the colors of the stoppage. So let me just click on this one. So this was a setup stoppage. You can see the start time, end time. Let me see another one. So this was a stoppage with an electrical problem. I can also see my cycle times. So I can zoom in the machine history tool, and I can actually see each of my cycle times. So it's actually about 30.1 or 30.31 seconds to 28.29 seconds. So it's changing. So for each of the production cycle, I can see my production amount. So there's a lot of other data here. So you can look at operators, you can look at technicians, you can see if there's a technician call, whether the machine was offline, if there are slowdowns within the production. So you can see all that. This is more like a short-term analysis tool, but the system lets you see each and every cycle of production. I'll just show you quickly the operator interface. So you can log into machine one. So the operator interface is by choice. It's a simple interface because the operators might also use a touch screen. So you can see the job, you can enter a stoppage, you can enter scrap, you can call a technician here. So if you operator cannot fix a problem by himself, he can call a technician. And a technician, if I go to online machine monitoring tool, if a technician is watching the screen, actually you can see this little icon here, which is a technician call, or the technician might be actually looking at this screen with this filter selected, which means actually now as soon as there is a technician call from any of the machines, it will pop up in the screen, and the technician will actually attend to this problem. Let me go back. Let me go back to machine one. So we also have for the operators, we have the capability to define scraps. We typically have a tree structure, and this is defined by the specific to the company. But our industrial engineers will help. And what that is okay. So by the way, I just got a alert from the system. So I want to open that. So there has been a technician call for machine one. The technician has not attended the call in the last 1 minute. So the system actually automatically sends this email since I defined it within the system. And I can have targets again for technician to attend to the call. So in this case, I set it up for one minute. So as soon as after 1 minute after I have the technician call, the system sends me the email. It actually shows me the technician alert within the system as well. And if I was using the mobile app, again, the system would have sent me that notification. So I can go here. I can define scrap. I can have unlimited levels here, but let me just enter one. Let me enter 50. Let me enter 100. So actually, the system won't let you enter more than a default amount because this is a real-time system, and we don't want operators entering scrap amounts in bulks. So there is only a limit that the operator can actually define the number of scraps. So now I have defined the scrap. Actually, I see another alert here, which means actually machine one has quality problems. For the work order, the scrap ratio is too high. Again, the system would alert whoever is in the loop for this specific topic. So as soon as I entered the scrap amount, it was higher than the scrap ratio that the company has been aiming for. So there's other information here, but let me show you some other tools. I would like to show a couple of reports within the system. So one of them is the TEEP waterfall, which actually gives a high-level view of the productivity within the company for for a machine or a machine group. So let me just select the time where there is data. Okay, so I have selected 1 week of data for 2 machines. So this is actually the total. Again, I got another mail from the system machine 1 quality problems. I'm going to close that one. So this was the total time that I had for 2 machines within 1 week. So there are 4 types of losses here. It's capacity losses, availability losses, performance, and quality losses. The first type of losses that I have are capacity utilization losses, where actually the company intentionally did not work for either holidays. There was no order. We were doing R&D activities. So in this case, holidays actually account for 20% of the total time. So my capacity utilization was 80%. So this is my scheduled time. So the first type of losses is my capacity losses was 20%. So my capacity utilization is at 80%. The second, so this part, the left side of the capacity utilization, the capacity losses are more like management or sales problems. So the manufacturing department is not responsible for these capacity losses. The second type of losses are availability losses, which these are the times where the machine was not available to work. So either in this case it's failure, setup, wait, a long stoppage. So anytime the machine fails or the machine is being used for setup or wait, or there are some long stoppages, these are the availability losses. So in this case, my availability was at 85%. So scheduled time after available losses are reduced, it's the running time of the machine. So this was the time where the machine was actually running. And the second type of manufacturing losses are performance losses. So this is for a given product, I have a target for cycle time. And if my cycle time is smaller than my target time, actually this would reduce my performance. So I want the machine to produce a product every 10 seconds, but the machine has produced a product every 11 seconds. That means my performance is less than perfect. So in this case, my performance was 94%. So this is total theoretical time. And then the last type of losses are quality losses, where I have scrap. So in this case, I had 1%. So my quality was at 99%. So I had 1% loss for quality. So my overall equipment efficiency, which is good theoretical time divided by scheduled time, is my OE. In this particular case, my OE was at 79%. My total equipment effectiveness performance is at 63, which is the time where I produced good product divided by the total time available. So OE is typically used for manufacturing performance. Total equipment effectiveness performance is the use of, or the effective usage of my machine. Let me show one last report, and I'll end the meeting at that time. Let me show you the one of the Paretos. So let's actually take previous month. Let's get the report. Okay, so this report, so I have shown you the TEEP, which is a high-level view of the system, but now actually you can go deeper and deeper, where I can look at what are my biggest losses in terms of quality problems, right? So I selected last month. Looks like my biggest problem was scratch problems, then missing piece, wrong color. And as you can see here, this actually Pareto gives you or orders the reasons from the most important to the least important. So if I were to do an improvement activity, I would actually be doing or attacking scratch problems the first. And if I can get rid of them, actually it would solve about 40% of my quality problems. And then missing piece and the remaining. So you can have the same reports for stoppage reasons. And then we have a lot of different reports, but I ran out of time, so I want to be respectful of your time. If you want to see the demo in more detail, just let me know. Thanks for watching, and we'll see you next time. Thank you.